I will start the the last part of this whole series. So this is the last 50 minutes. All of you must be tired, but it's just a little bit more. So just bear with me for another 4 kernels, and you will have a proper FMM code working. And yeah, so we've done P2M and M2M, so I'm just going to go to M2L. M2L is a bit more complicated. It's longer because, so remember, we have the derivative of G in this kernel, and it's sort of written in this code, but it gets very long when you write it like this. So, okay, so I'm going to gradually move to this, and so the dx and the dy will be calculated. So I can erase the original kernel because I'm no longer using it, those things, and so I'm just going to code according to the thing I'm seeing on the left. No, seeing on the right, and copy it to the left. So M Oh, there's something I haven't defined. Inverse of Z. How is that defined? Oh yeah, I'm actually defining many things here. Okay, let me make sure that I copy these 2 things too. Okay. So I have this thing, and also the inverse is defined as this operation here, which, so, or do I have another thing? Where is POW ZN defined? Ah, here, okay. So I have many things here. No. So it's just that this thing is defined like this. Okay. So it's a little bit different from the M2M in the sense that I have to define all these complex numbers before I start the calculation. But then these are being used in like a recurrence relation, and then that's why I need POW Z, which is probably going to be used in a recurrence relation for n only, and the POW Z nk is going to be used inside the double loop of the recurrence relation for both indices k and n. Okay, so again, I'm going to define, so I'm going to have a loop for k and n. K starts from 2 in this case. K. So I'm just copying basically the code. I'm just looking at the code on the right and copying, and I'm doing this manually because I think it's faster than doing copy and paste to do it this way. Because of the small differences, basically. So if I copy and paste, I'll need to do the correction anyway, and I think typing in will give me less bugs. Okay. So if anyone sees me typing something wrong, then please let me know, because I may make a mistakes at some point. So what is this? Yeah, I think for this part, copying is faster. Okay, so I'm done up to here. I think this is almost, yeah, so this is the end. Okay, so now I have the M2L kernel. It was like, what, about 30 lines of code. It's still 30 lines of code. It's not like excessively long or anything. It's, okay. I just need to make sure everything is correct. It's always good to double check after you copied something, because copying is the source of bugs. Okay. So I'm going to try to compile, because the M2L is the most complicated part of the code. I'm getting some strange numbers, and I don't know why. So this is, now I have to start debugging. So it could be because the M is already wrong in the previous calculations, and when I do M2L, it actually substitutes numbers into the L0, so it actually changes the results. So, well, there's something wrong with either the numbers that are being input here, so maybe I can just go back to P2M and start printing stuff, because the error could have happened starting from P2M, because we've been changing the values here. So first, let's just confirm that the Z is correct. So C real will print the real part, and C imaginary will print the imaginary part of Z. So if I do this, or maybe if I write like this, it would be more familiar. Okay. And then, okay, so this doesn't look that strange. It's just outputting all the X and Y values. Yeah, this looks okay. Because it's the distance from the center to the points, it shouldn't be that large because they're both 2 points inside the same small box. Okay, so it shouldn't be like, you know, close to 1 or anything. So these numbers look okay, and it's the proper complex number. Okay, so now let's try to look at the higher order terms of n. So before we do that, let's see if Pao Z is being calculated correctly. Okay, and then we can output the n here, so okay. So because P is 3 right now, it's only going to loop over 1 and 2. And the numbers look okay to me. Now let's print these values here. Okay, so there's no strange numbers here. So it seems like something strange happens here. Now the first thing to check is always, you know, to check if Z is again correct. Yeah, it looks okay. Okay, so here I'm seeing infinity. Okay, so I think this log function is not calculating the complex log. Yeah, in C++, I'm using C++ and other code, so it's okay there, but it seems there's something wrong with this number that's being calculated here. Yeah, I think the fact that it's not returning any imaginary values means it's probably not calculating it as a complex. Ah, maybe I can use this thing. Oh, good. Now it works. Okay, so I just had to add this this extra header file, tgmath. I think it works in most compilers. It should. You can try include tgmath, and then the log turns into the proper type. You know, the log, it turns into a complex log properly. Without this, the log tries to do like a not complex, you know, like a real number log, and it fails. So now I should not be getting strange answers here. Except I probably won't be getting correct answers either, because one main thing is that, yeah, I first need to change the P2P kernel, because this complex number that I'm using is also not 1 over r. It's the proper 2D Green's function, so it's the log r function. Where's my P2P definition? Here, yeah. So this needs to be like a log. Okay. Now I should be getting matching answers, I think. No? Okay, well, maybe I'll just proceed and see if they match in the end. Okay, I'm going to move to L to L and see. Okay, so I need to define similar things to the M2M kernel. Okay, complex POW and loop Okay, now L2P. It's just one more, and then I can debug. So this is almost the same as the P2M. You just take the power, which is like the power of z and the factorial n, and just add this to u. So these are the high order terms coming from the high order local expansion, L, and just multiply them to pow z and they should be the correct, yeah. Okay, so this should be giving the correct numbers. Okay, now let's check if see if we can debug the answer. Okay, it's giving strange numbers again now, and we can see why. Yeah, hopefully we can debug this by the end, and then we'll have everything working. Okay. So if I don't have any high order terms, it should still give us the same answer. So we can debug this in different stages. We can, if I don't sum, okay, I shouldn't be summing starting from 0. That's one thing. Okay, okay. Okay, so there's now some difference that is probably coming from the difference in the definition, because this code is working like this on its own. So there must be some mismatch in the definition of things. So like the dx I changed here, and dx here I also changed cj minus ci. And here onwards it's okay, because dx is always ci x minus cj x, also in the L2L kernel it's ci minus cj, and here it's b minus the c index. Okay, so one thing we can do is to first try to eliminate all high order term. There's an easier way to eliminate high order terms. I just set p to 1, and it should reduce to the original equation, except we're now using like the log function, so I need to check if that one is working, basically. Yeah, okay, so there's a problem even with just the first order. This one is just calculating m0, and for this one it's just, also m0, and then this one is calculating basically this minus log z.